Okay, okay. Hey, Mr. Aker, it's me, Stathis. This is Seyadul. Looks a little dark, but you know, okay. No, seriously, look dark, Seyadul. It's dark out.
Oh,
Don't think that as a joke. It's not funny. Racism is not funny, Seyadul.
Yeah, I found that out a while ago.
Anyways, okay. So here's our base that everything's gonna go on to. So it's raised just a little bit with some
Pegs?
bolt nuts, and then it has a plug to take the water out after the pond has been filled. There's the plug right there. And then here is a little peg that we support our quote-unquote water supply from. So here's the water supply that Seyadul's holding with water in it. You can see it's just an old Mountain Dew bottle. So, and then it's on a frame that holds it to the peg. So Seyadul, put it on there, and I'll attach it in there. And as you can see, there's a little hole, and there's 3 little pegs that you can plug it into. And I'm gonna put it on the bottom one. Put it down further, Seyadul. Hold up. A little bit further down. A little bit higher. There it is. Okay, so now that's secured in. So now that has become one with the board. And then here is our pond, completed and everything, shut off from all sides except from the bottom. Show them the bottom, Seyadul. Obviously that won't be on there when we attach it to the board, because it's gonna be permanently attached to the board with glue or silicone. And then just put it on the board. And then when it's on the board, here's our stop nozzle that turns to let water in and out. Well, hold on, I can't really turn it. There we go. And then that's off. Oh wait, did that just leak in? Oh yeah, it probably did. But anyways, and then it's really easy to take this in and out to refill the bottle. So you can just pull that out of the hole and in. So that is
How it works.
yeah. But okay. So it says explain and show the problem here. It says okay. In addition, please, or the problem and solution should be discussed. So I guess we're going to discuss the problem and solution. Here you go, Seyadul. So, how about you just read it off to the camera?
An artificial pond is 10 meters long, 20 meters wide, 3 meters deep at the ends, and 8 meters deep in the middle. If the pond is filled from a water tower at a rate of 25 cubic meters per second, and the B of the pond is rising at a rate of 17 meters per second, how fast is the water level rising when it is 4 meters deep at the ends? The length of the bottom of the pool is 7 meters.
Okay. So then we start off with the original equation. Volume equals half base 1 plus base 2 times width times height. And then here you can see that B1 equals B1 equals 17, B2 equals 7 right there. And then L equals 10, W equals 20, and height equals 5, and then
Change in volume is equal to
25. Okay, so then we multiply out all those variables. Then we take the derivative of the volume, which is half, and then you have to do the chain rule, or I'm sorry, the product rule for 3 products. So that equals that, and then carry out the half for everything. And then everything that has a 0 in it will cancel out because obviously it becomes 0. So then you're left with volume equals half derivative of B1 times 80 plus half derivative of H times 20 plus half derivative of H times 140, which then equals, and then you replace the derivative of V with 5, which is the rate, or 25, which is the rate that the volume is changing at. So then the derivative of B1 changes to 17. You just plug that in. So then 25 equals 680 plus half derivative of H times 100 plus half derivative of H times 70. Then you move the 680 to the other side, and you're just left with a simple equation on how to solve H. And then H can be found to be negative 0.094 meters per second. And here's just a little diagram of everything. So, I'm gonna go ahead and assume that that concludes the problem and solution being discussed. And here you can see that, you know, once you move the water from the water tower into the pond, you can figure out by simple math and by visualizing at the 4 centimeter mark, because the model scale is a 1 meter to 1 centimeter scale, you can figure out the solution. So I guess that's it. Let's just have Seyadul and I pose here. So thanks, Mr. Aker. This is a fun project.
Fun.
So we'll see you on YouTube. Say bye, Seyadul.
Bye.
I made Seyadul eat a hot dog.
A pork.